Hello everyone, today we are discussing about the motional EMF, and this motional EMF we are obtaining from the Faraday's law of electromagnetic induction. Here we have a magnetic field which is perpendicular to the plane, and here rectangular coil is placed in between this magnetic field. Suppose if I am taking this rectangular field coil as a B, C and D, and here at we are keeping one adjustable end, and this end can move inside or towards the BC or moving away from the BC. And here pull or push, that means velocity which we are providing to push or pull is V, and the rectangular coil has a length x and whose breadth is nothing but L. So this is what the diagram to obtain the expression for motional EMF. So here the EMF induced across the ends of a conductor due to the motion of the magnetic field is called as a motional EMF, and we have to derive the expression here. E is equal to BLV. E is a EMF or motional EMF, B is a magnetic field, and L is a length of this breadth of this coil, and V is a velocity. So here uniform magnetic field is there which is perpendicular to this the perpendicular magnetic field to this plane. So here if we write, or if suppose this rod, suppose this is a rod, AD is a rod which is what, movable inside or outside. So this rod AD is perpendicular to the plane of this magnetic field. That means whenever you are moving towards the BC or you are taking away from the BC, due to that number of field lines are gets cut or number of field lines are increased according to your movement. So if there is an increase or decrease of the electric field lines, that means there is a generation of flux phi, and that flux phi is nothing but B into A. So B is nothing but what, the magnetic field, and A is nothing but area. And here we can write B, and area is nothing but we can write length into breadth, okay, L into X. And we know that if we are changing the rod AD towards BC or away from the BC, then the EMF, due to change in flux, there is a EMF induced, and that EMF is equal to minus d phi by dt. And here phi is nothing but B into A, and this B into A is nothing but B into L into X. So I will keep here this phi value as a B L into X. So we know that the magnetic field for this given experiment is remains same. So we can take this magnetic field as a constant outside, and length, this breadth is also remains same, okay, and inside that X will keep on changing because the rod is what, we are moving towards the BC or away from the BC, so that length X is keep on changing. So this is nothing but what, the change in distance with respect to time, and this change of distance with respect to time is nothing but what, velocity V, distance by time. So we can write here E is equal to minus BLV, or if we are taking mod, then we are getting BLV. So this is the expression for the motional EMF by using Faraday's law of electromagnetic induction. This derivation is very important from the exam point of view. Thank you.